Alright, this is the first time we've gone through exercise 3A, the start of it, and it's an extension of 3A, looking at expanding perfect squares and difference of two squares. Now, Keely, what defines a quadratic? What makes a quadratic different from a linear equation?
The power.
Awesome, the power. So, if I'm looking at a quadratic equation, we know it's to the power of 2. Have you guys heard of the term parabola before? Yes? No? Yeah? So what is the difference between quadratic and parabola? I didn't talk about that last lesson. Yeah, a quadratic is the equation itself. The parabola is the graph. Now, it doesn't really matter the distinction between the two of them. If you say quadratic or parabola, we all know what you mean, but that is the distinction. So perfect squares and difference of two squares. I'm going to give you guys a little bit of time. I want you guys to try expand both A and B. So just do A and B. And then afterwards, we'll continue from there. So just do A and B now. All right, so the first one, we're expanding. We're expanding perfect squares. So in this case, I've got A plus B squared. If we go ahead and solve it, or expand it rather, we end up with A plus B times A plus B. We all good with that? Lovely. So A times A gives me A squared. So this is using FOIL. So first is A times A. Outer is A times B. Oops, sorry. Plus, and then A times B again, and then the last two multiplied gives me B times B, gives me B squared, and that therefore gives me A squared plus 2AB plus B squared. Are we okay with that? Yep. So the difference, so the expanding perfect squares tells me that A plus B, or squared, gives me A squared plus 2AB plus B squared. And this is applicable in different situations. Now, you can just expand it by hand every time. That's what I do. Or you can just use this formula. It doesn't matter. So this is our first formula that we're looking at, where A plus B all squared gives me this quadratic over here. Okay? Now, the second one, I've got the difference. It's pretty similar. The only difference is that the second one is a takeaway, as opposed to the first one. So the first one is both positive. I don't like how it keeps zooming out. There we go. Both positive, where in this case, I've got a positive and a negative. So you should end up with something that's shorter, and they cancel each other out. So let's go ahead and expand it. So I've got A times A, so A squared. That's first. Outer, I've got A times negative B, so negative AB. Are we okay with that? Awesome. And the middle, I've got A times B. They're both positive, so I end up with positive AB. Multiply the last two, I get negative B squared. So positive B times negative B. If we simplify that, we end up with A squared minus AB and plus AB cancel each other out, so minus B squared, and that is our second formula. Now, the reason why it's important that we actually remember or note these formulas here is because when we're factorizing it later on, we're going to go backwards. More so with the second equation, but we're going to go backwards. So if I'm presented with something that looks like this, you should be able to identify, okay, it's a difference of two perfect squares. What if I put it back into this form right there? Because they are the same. I just expanded them. I haven't changed any values or variables. They are the same. With that understanding in mind, I'm going to go through part C and D. So part C, I've got 3x minus 2 all squared. You could use the formula where we define A as 3x and B as negative 2. Let's go ahead and do that. So I'm going to say A squared. So that's using this formula over here now. So A squared, instead of writing A, I'm going to write 3x all squared plus 2 times, instead of writing A, I'm writing 3x again. Instead of writing B, I'm writing negative 2 plus, and then instead of writing B, I'm writing negative 2 all squared. I'm going to simplify that. 9x squared plus positive 2 times by negative 2 times by 3. I know I'm going quite quickly. Is negative 12 x plus 4. And that's going to be our expanded version. So that's what I've used. I've used the formula. So I just define, okay, well, we've got this first section over here. That's my A. I've got my second section over here, including the negative, is my B. I substitute it in the equation. I can do that. If you want to expand it out normally, you can do that as well. It's up to you. Now, part D is going to be expanding of our variables over here. I'm going to do the same thing. I'm going to define A as 2x, and then define B as 4. Okay, so from here, I know I'm going to use the formula of A squared minus B squared. So now I'm going to replace A. I'm going to write bracket 2x all squared minus, and for B, sorry, I'm going to write 4 all squared, and I end up with 4x squared, take away 16. That's it. Any questions? No? I'm going to move on to introducing exercise 3B from page 87 of your textbook, but I'm going to use the booklet that I've given you at the start of the year. So in our booklet over here, I'm going to get you guys to go to, if you have the booklet, go to page 7. So it starts with quadratic and quadratic equation forms. Now, if you don't have it, that's fine. Just look at my screen over here. In our success criteria, I've listed that we need to be able to factorize quadratics by using common factors, grouping terms, difference of two squares, and factorization of quadratic polynomials. Now that sounds very complex because a couple of them are, but some of them are really easy, stuff you've already done before, particularly common factors. So let's put that into practice. I'm going to skip the examples over here. We just went through a couple of them of the same nature. I'm going to go straight to factorize the following. And I'll refer back to the quadratic equation forms later into the topic. So 9x squared plus 81x. And now when we're factorizing, obviously it means let's shove stuff into brackets. Make it more simple, make it more easy on the eye, essentially. So if I'm factorizing this, what's a common term? 9, is that it? Yeah? Is that it? Sorry? 9x, thank you. If I was to take out 9, I could just take out 9, but I still have x squared plus x in the center. So let's go ahead and take out 9x. So 9x, that's a common term, so I'm saying 9x squared divided by 9x gives me just x. Think about it this way. X times 9x squared is 9x. Sorry, let me repeat that. X times 9x gives me 9x squared. Awesome. What's 81x divided by 9x? So what's 81 divided by 9? 9. The x cancels each other out, so I just end up with x plus 9 there. Bam, that's already factorized. 9x times x plus 9. If I was to expand that, you guys don't have to do this obviously, but if I was going to expand it, I'd say 9x times x gives me 9x squared, and then I've got 9x times 9, which gives me 81. So the same idea, but we're going backwards. This second one's a little bit interesting. This is what we call grouping of terms or grouping by terms. There's a fly right in front of me, it won't leave me alone. So x cubed plus 4x squared minus 3x minus 12. What do you notice is different between this equation right here and something we're more familiar with, the ones we've been working on before? Multiple terms, right? There's 4 terms now, and also it's to the power of 3. It's a third degree, right? We're used to working with first or second degree. So now I'm going to separate these into groups. So I'm going to draw a line right here. And in future, you're probably going to have to be able to separate them yourself. But let's focus on this. So I'm going to draw a line right there. Let's focus on the first half. So ignore the second half. X cubed plus 4x squared. What is a common term? What's a common term? Sorry, a common factor. X squared, is that it? Yes, not a trick question. Yeah, that is it. All right, so x squared, bracket, x cubed divided by x squared is? 4x squared divided by x squared is? Are we okay with that? Lovely. Now let's focus on the second half. I've got negative 3x minus 12. What's a common term? Common factor, sorry. I don't know why I keep saying term. Negative 3. Do I do negative 3 or positive 3? Ooh. Let's try out both, right? Let's do negative 3 first. So take out negative 3. What's negative 3x divided by negative 3? X. Negative 12 divided by negative 3? Good. Now the thing is, right? It gets really complicated with the negatives, so you need to make sure you're on top of that. If you need to write extra brackets, do so. That is where most people mess up these kinds of questions. What do you notice about this equation now? It's similar, and we've got, Kaylin?
X plus 4.
Awesome, x plus 4 on both sides. Now, this is the correct method. I'm going to go ahead and do positive 3, okay? So someone suggested earlier, let's go ahead and give that a go. So I had x squared bracket x plus 4. If I take out positive 3, this would be negative x, and then this one would give me negative 4. And in that case, these are not the same, right? So that's not what we want. We want them to be the same. So I'm going to get rid of that. And really, some of it's going to be trial and error. That's fine if you get it wrong. So let's get rid of that. And we've got x plus 4 being the same on both terms, right? What we're going to do is we're going to say that because these are the same, I'm going to take that out as a common term. Same as what we did before. Take it out. So I'm going to divide both terms by x plus 4. So equals x plus 4. Are we okay with that? Yeah? So I've crossed that out from both of them. What am I left with? Well, x squared minus 3. That's it, I'm done. So I've divided both terms by x plus 4, that common term, or common factor, sorry. Taken that out of the bracket, and then left that in there with x squared minus 3. So that's using grouping. This one over here is a little bit interesting. This one is difference of perfect squares. So do you guys remember using this formula right here? We've got a squared minus b squared equals to this thing over here, right? So what I'm going to do is I'm going to work backwards, okay? Right now, I've got 9x squared, minus 36. Would you agree if I said that that is the same as bracket 3x all squared minus 6 squared? Would you agree that's the same? Yes? Awesome. Now what we've got is we've got this, a squared minus b squared. Remembering that equals to a, oops, that's ugly, equaling to a minus b, a plus b. Now does that matter if I write minus or plus first? For example, is that different from a plus b, a minus b? No, it's the same thing, right? So let's ignore that, let's just use one of them. I've got a squared minus b squared. Let's define a equals to 3x and b equals to 6. Are we okay with that? Where did I get these? How did I define a and b? Where did I get that from? It's in the same form as this equation. Yeah? So I'm saying that all of a squared minus all of b squared gives me that. I'm going to define those variables as that. With that in mind, I get, where are we up to? There we go. A, so 3x, take away 6, and then 3x plus 6. That's it. Any questions? So that one's a little bit trickier. We're going to move on to something called cross method. Do you guys need a little bit of time to copy that down? Yes. Yep, I'll give you guys. Okay, so now we're looking at the method of cross method. Okay, something that's a little bit confusing. The first thing I'm going to look at this do with this equation. What's something I can do with this equation? I can take out a common factor, right? What's the most common factor? 2. I'm going to take that out. X squared plus 6, not 6, sorry, 3x minus 10. Now I'm going to focus on this equation right here. The x squared plus 3x minus 10. I'm going to write that up here actually. What we want is we want it in the form of bracket something bracket times by bracket something bracket. That's what we want. That's factorizing it. We have to do something called cross method, and you will learn later on that there are different methods going about this, but I'm going to teach cross method and then teach the other method. We want it in that form. What we need to do is we need to have two terms, so factors of x squared on this side of here, and this side I need, jeez, what happened there? Factors of negative 10. Okay? So what are the factors of x squared? What could be the factors of x squared? X. So x and x. I'm going to write x and x over here. Now when you do this, you don't have to write out all these words. You can just do it however you like, but I'm just going to teach it this way. What are the factors of negative 10? There's a lot. There's a lot, right? Realistically, there's 1 and negative 10, negative 1 and 10. There's a lot. But let's focus on this as an example. Let's do positive 5, and negative 2. What we're going to be doing, the reason why it's called cross method, is we're going to cross these and multiply them. So what's x times by negative 2? Negative 2x, easy. I'm going to write negative 2x over here. What's x times by positive 5? 5x, positive 5x. What we need is we need these two variables. And remember, these could have been any values. We could have found any factors of 10, negative 10, sorry. We need these two to add up to this value in the middle. It's a bit confusing, I know. So what's 5x plus negative 2x? 3x. In this case, that is correct. It is correct in that those values are correct. I'm going to draw a line in the middle, and I'm going to take these right here. Okay? So I'm going to end up with x plus 5 and x minus 2, and I'm going to put brackets in between them like that. That's cross method. If I expand those two factors, those two brackets, you would end up with x squared plus 3x minus 10. I'm going to do one more example with this after this, but that's what you would get. However, in the question, remember there's a 2 at the front, so all you have to do is add a 2 at the front and you're done. So that really is just practice. You need to practice your cross method. Would you guys like to do one more? Yeah? Okay, let's do one more. So let's do x squared, take away 2x, minus 8. So over here, same idea. What are my factors of x squared? X. So I'm going to write x and x. Now I'm going to ask, well, what are the factors of negative 8? Well, let's start with, what are the factors of 8? 4, 2 and 4. Yep, what else? 1 and 8. Okay. Remember, we're going to be adding or subtracting whatever, we're going to do some combination with the positive, negative number, whatever it is, in order to get negative 2. Is there any possible way, because 1 and 8 are factors, and 2 and 4 are factors, right? Yeah, those multiply together, sorry. Is there any combination of positive 1, positive 8, negative 8, whatever it is, 1 and 8, that give us 2? No. You could have negative 1 and 8, that's going to be 7. Positive 8, negative 8 and positive 1, negative 7. There's no way. So, I'm going to focus on these two. Does that make sense, what I just said? Yeah? Because we're looking at them as multiples. 1 times 8 is 8. 2 times 4 is 8. You can't have 2 and 8, because that would give you 16. So I'm going to focus on 2 and 4. Some combination of 2 and 4 will give me negative 2, because that's what we want. We want negative 2. Say that again. Say that again, Megan. 2 minus 4. I'm going to say negative 4 and positive 2. Are we okay with that? So 2 and negative 4. And the reason why we do the cross method is because later it gets a bit more confusing. But we're going to focus on this first. So x times negative 4. Negative 4x. Thank you very much, class. Over here, x and positive 2 gives me? Thank you very much. Positive 2x, that gives me negative 2x. That's perfect. That's what I want. So I'm going to draw a line over here. I'm going to write x plus 2, and that's from the top half over here. And then I'm going to do the bottom half and write x minus 4. And that is the same as that. That's cross method. I'm going to go back to the other one, where we had x squared plus 3x minus 10. I'm going to write that out. X squared minus 3x minus 10. We use cross method, right? We said, okay, we've got x, positive 5, negative 2, and that gives us x plus 5, x minus 2. That's what we said, yes? Guys at the back? Thank you. What we can do now, we can do the same thing, but by grouping. We can force our own group. Do you remember earlier, we drew a line here because it was presented nicely. We drew a line, we just took a common factor from first half, common factor from the second half, and like, oh, look, they've got the same term over here, and therefore we can put them together. Do you remember that one? Yeah, that was like 5 minutes ago. Awesome. So I'm going to do a similar thing, but I'm going to force a grouping. I'm going to separate them. So I've got x squared minus 3x minus 10. What I'm going to do instead is I'm going to aim for like an x plus 5. I'm going to try and get an x plus 5. So over here, x squared minus, let's say I'm going to write x squared minus 5x. If I factorize that, what's a common term? X, I take it out, what do I end up with? X minus 5, right? So I'm going to aim for that. So perfect, we've got that, down pat. I've got negative 10. I can't do anything with that yet, so I'm going to write negative 10. What value does this have to be? What value does has to be next to the negative 5x in order to make it the same as negative 3x? Plus 2. I'm going to write plus 2x. Would you agree those are the same things? Yeah? Same thing, I've just expanded out really weirdly. Now, I'm going to go ahead and say, okay, I've got x squared minus 5x plus 2x minus 10. Take out the x over here, I got x minus 5. Yeah? I'm going to take out the 2 over here, and I get x minus 5 again. Do you guys notice what I'm doing? Yes? No? Yep? Lovely. I'm going to do the same thing as before. I've got x minus 5 on both sides. I'm going to cross those out and write it over here. And I end up with x minus 5 and x plus 2. That is the same answer as before. You can pick whichever method you want. I will never deduct marks from whichever method you do, unless otherwise specified, but they both work. I personally do cross method. I know Mr. Weatherall personally does grouping. You can pick whichever. There's no wrong or right answer. Any questions? No? There's one more concept I really want to drill into you guys about this before we move on and let you guys do some work. This one? Yeah. Lovely. So over here, I've got x plus 1 or squared minus 2x plus 1 and then minus 3. You could, most people would look at this and think, okay, I have to expand it all and then factorize it. You don't have to do that. What I'm going to do is I'm going to say, let's define this x plus 1 as, let's say, a. So let's x plus 1 equal to a. If I substitute that into our equation, I get a squared minus 2a minus 3. You guys noticing what I'm doing? Yeah, I'm making it simple for myself. And then we'll deal with the x plus 1 later on. So, let's use cross method. What values multiplied to the a give me a total of negative 2? So I'm thinking, what are the factors of negative 3? It's got to be 3 and 1 somewhere, right? It's because to figure out which one's positive, which one's negative. Yeah? Zora? Yes? So I'm going to figure out which one's positive and negative. Let's just give one a positive, give one a negative for now. What's a times positive 1? Positive a, yep. And this one over here? Negative 3a, awesome. What do they add up to? Negative 2a, that's exactly what I want. So I'm going to write equals a minus 3, and on the bottom, a plus 1. Now all I have to do is I have to substitute that a back in, because we're not looking for a, we're looking for x. So I'm going to substitute, remember, a that equals to x plus 1, so equals to bracket x plus 1 minus 3, x plus 1 plus 1. Are we okay with that? Yes? No? Yeah. And then we just simplify that. Bracket x minus 2, x plus 2. I know that's a lot of content. I'll give you guys some time to just work it out, take a breather. But do I have any questions for now?